Welcome, fellow agents, to Codename Project APS342. We hope you're in the right room. We're very excited today to spend time with you to focus on application security and specifically how it can be practical. But even more further, we're going to go on an impossible mission today. I'm Agent Webb, and I'm joined by Ethan Hunt. Who are you?
Hello, everyone. My name is Milos. I'm the application security engineer from FINRA. I'm really looking forward for today's session, where we can see how we can leverage AWS Q/review agent to find and identify, mitigate security vulnerabilities in our code base directly inside the IDE.
Different agency, I see, not with MI6 again. So today we're going to be covering 3 specific vulnerabilities and different mission agendas that we're going to be covering. Now, within this mission, we're going to first give you an overview of Amazon Q Developer. And to get us started, who here has used Amazon Q Developer before? We have a few people in the room. Okay. If you're a security analyst, would you raise your hand just so we can get a sense of who's in the room? All right, maybe a developer. Okay, so a few developers, or maybe more in leadership. All right, so a little bit mix of both. Well, today's session is going to talk about how we can use Amazon Q Developer to really help us solve these mission objectives that we have. And at the very end of this session, we're then going to focus on how can we actually take this to the field and what is going to be useful for us. So today we're going to spend some real time going through actual code examples today that you'll see so that you can understand how we can solve these missions. So Amazon Q Developer is our generative AI artificial powered assistant that helps you throughout your software development lifecycle to be able to do things like get code suggestions, as well as generate net new code and work on your code bases. Now, one of the things that we're doing is within the IDE, and as you work with Amazon Q Developer, we're really trying to shift left the idea of how can we get the security process to developers sooner. So rather than focusing on, hey, I am passing all my code over to a security engineer, how can I get that ahead of the game so that I can focus on my code and ensuring that it's secure? Now, Amazon Q is powered by Amazon Bedrock, which is our foundational model service that allows you to run models through an API. And so what we're going to be doing today is focusing on how Amazon Q Developer can solve these strategies, and specifically some agents within Amazon Q Developer that you can rely on. Now, Milos, can you tell us a little bit about your experience that FINRA's had with Amazon Q Developer?
Absolutely. Thank you, Michael. Being a long-term AWS partner, after initial rollout of the Amazon Q Developer, we were very interested in testing it, which we did throughout pilot or project, POC project that we did. Across the 15 application teams, around 70 developers were involved throughout testing through the fall of 2023 and the summer of 2024. We were very satisfied with the initial results, and that's why we expect by the end of this year, 2025, to have around 1,000 developers, engineers actively using Amazon Q Developer with daily work and just tasks.
Awesome. So Agent Markovich, that sounds like you've been in the field a while. So really today, I think what we're going to cover is these missions and how we can resolve these specific objectives with Q Developer. Let's introduce you to the team that we have today to help assist us. So, as many of you are aware of, within Q Developer, you have these different agents that, we might have had a few agents. Seems like some of them have gone missing or are rogue. So we have a few agents that existed, or that still do exist within the IDE. Those are the dev, test, doc, and transform agents. And these do different functionality. So you have your dev agent that, for example, writes code for you, net new code. Or if you want to build unit tests, you can use something like /test. As well as /doc to generate documentation, as you can see there. But today we're going to be focusing on the /review agent, and specifically what this /review agent can do for you as you're going throughout your development lifecycle. So Amazon Q Developer Agent can review your code base. It has very unique functionality. It has SAS scanning. It has SCA, software composition analysis, capabilities in it, so that as you're going through and writing your code, you can actually generate and ask Q to generate a kind of review of your code in your workspace. And you're going to see today, as we go through this actual demo and going through this code talk, how we're going to apply those specific principles throughout the examples that we have today. These missions are going to be challenging. Now, we're not going to be able to solve all of the OWASP top 10 today, But with today, we want to get you started on a journey as new recruits to be able to understand how you can utilize QDeveloper in your workflows so that as you're going through and as you're writing code, you can also have another agent there beside you, such as the /review agent. Now, with the /review agent, we want to ensure that we're detecting the potential security vulnerabilities. And so rather than just having generative AI that is being able to look at your code, we're also using automated reasoning capabilities to be able to ensure that it goes against some of the testing strategies that we have and that we've trained these models upon within Amazon. Now, with that being said, Agent Markovich, would you be willing to lead us through the IDE and kind of what that looks like?
Sure, absolutely, Agent Web, if you can just unlock the laptop.
Security first.
Of course. So here, for today's presentation and demo, we'll be using the Visual Studio Code as an IDE, but any IDE supported by the Amazon Q extension will work just fine, such as the Eclipse or IntelliJ. We already, prior to the presentation, installed Amazon Q extension, which we can see in the bottom left corner. So if I just click on the Amazon Q, that's going to bring additional menu panel. From here, we want to go to open the chat panel, which brings the chat panel here. We already ran the review scan before, so I'm going to close these findings very quickly and start from the very beginning. So this is a chat panel. Now we can start utilizing Amazon Q by crafting our prompts and inputs. We're asking the questions about our code base or just general questions that we have about AWS services or code in general. As Michael was saying, we also have different agents at our disposal. We can start using different agents by typing the /, which gives us a few options here that we see. For example, /dev, test, doc, transform, and the focus on our presentation today is going to be the /review. We can see here the /review next to it, there is a small description saying to identify and fix code issues before committing. That's very important because that's all about the shift left mindset, where we want to get these vulnerabilities when developer starts building new projects and new features at that point, because we want to release additional burden on security teams having to identify and then security vulnerabilities, and additionally work with developer on mitigating those, which can also be additional work on the dev team as well. So here, if I just click on the /review, this gives me two options. We have the first option to review the workspace, and the second option to review the active file. If I decide to go with the first option, review the workspace, that's going to kick off the security scan of my entire project I have loaded up inside the IDE. Every file, folder, directory is going to be scanned for security vulnerabilities. Now, completion time here ultimately depends on the project size, and it's also going to increase proportionally with your project size as well. So if you have, for example, a small project like we have today, it's going to be pretty quickly to the medium project size. Otherwise, with the huge projects, with thousands of lines of code, it may take some time. The other option to it is review active file. Review active file is going to kick off security scan for the active file that we have in focus inside IDE. So for example, you can see here we're dealing with a Python application today. So if I have Python file open here, it's going to only look for vulnerabilities in that specific file, which can be handy. For example, if you use the review workspace already, you have a bunch of findings, you already are aware of these findings. But let's say in the meantime you build a new feature, new functionalities, you want to scan specifically that file, you can also do so, which is going to also decrease the time that you have to wait for security vulnerabilities.
That would really be helpful if you had a large project. Right?
Absolutely.
And it sounds like we have a project that we're going to be working on today. So Agent Markovich, would you lead us through what this project is and what it does?
Sure, absolutely. So what we have here before kicking off the security scan is our small book vault application. We think it's very important to give the overview of the application what we're dealing with today for our secret mission to mitigate these 3 vulnerabilities critical as the highest before we start. So I'm going to start with the code base from the file explorer directly inside the IDE, and I'm going to hand off to Agent Web to give us a demo from the end user perspective directly into the browser. So here we see, as I mentioned, this is a Python Flask application. We see it's pretty straightforward and simple. We have the app.py as a main functionalities and logic in our code as a backend. We have requirements.txt where we define 2 libraries that we have, specifically Flask and PyGWT with their respective versions. Flask, as this is a Python framework, and then PyGWT for handling the JWT operations within our application. Additionally, we have a schema SQL, which is going to be initiated when we start the application to create some demo users and some demo data. And finally, we have a templates folder, which some HTML static files that are going to be used for rendering the data coming from the backend. Before handing off to the Agent Web, I'm going to start the review of workspace security scan. So while he is giving us an overview of the application, the security scan will be running in the background. So how it works, we can go ahead and choose the other option. For today's demo, I'm going to stick with the review the workspace. And as soon as I click it, we see the 3 different stages: initiating the code review, reviewing your code, and processing review results. And then we can see the workspace review is in progress. And now, while this is happening behind the scenes, AJ, can you please give us an introduction of the application itself?
Definitely. One of the things I really like about the slash review agent is that it works asynchronously. So while I am focusing on other tasks or being able to complete other items in my workload, I can actually let this agent asynchronously go out and do its own thing. So let's go into the, oh, look at that, it's already completed. That's okay. We're going to give you an overview of the application. So the first thing I'm going to do is I'm going to open up a new terminal window to start our application. Now, as we can see here, we've already activated our virtual environment. So we'll go ahead and open up our app.py, and we'll go ahead and start this application. Let's go ahead and jump into this application that's running locally. Ladies and gentlemen, welcome to the Book Vault. The Book Vault is a place that you can secretly store all of your books. By being able to log in, for example, with other agents, such as Agent Angela, who works with us, we can log into the Book Vault, and we can view the books that Angela has access to. Now again, Angela gave me her password, not a best security practice, but as we go through, we can see that these books are stored, and we're able to then see what she's going to add to her library. Additional functionality may be needed, or we may be implementing things like creating new authentication methods. So as we come in here, we can add a new book. So let's say, for example, I wrote a new book called Frindle, which is a favorite of one of my children right now. Hopefully they don't get compromised by me writing that out. But I can go ahead and add that book. So now I have a book in this web application, and as you can see, we can see this list of books that's now been added to Angela's specific profile. Again, I can log out, and if I needed to, I could also register and create a new account. So very simple application, but today's mission, Agent Markovich, is for us to solve these specific vulnerabilities that we're dealing with and seeing how Amazon Q Developer can help us. So let's go over mission number 1. So, ladies and gentlemen, we're going to start with mission number 1. The first thing that we're going to be resolving is SQL injection. As we know, SQL injection is a common thing in the industry, and that sometimes is overlooked, but is a very specific and common attack that exploiters or attackers try to exploit so that they can get into our databases or do different things. And so today, we're going to be seeing how their SQL injection that's actually encrypted into our book vault to be able to secure that so that we don't run into that same problem. Agent Markovich, do you want to go ahead and lead us into that and show us how that's being done in the field today?
Absolutely. Thank you, Agent Web. So let's go ahead back to the IDE. But before I do a deep dive into the SQL injection specific finding, let's also take a look at what we have as a result of our security scan. So we have our terminal where the application is running, and then we can go ahead and check the scan results. We see that we have 7 total findings among the criticals and highs, and then we also see the 4 among the mediums and lows. When we start a security scan with /review agent, the findings are going to be populated across different 5 groups, with the most critical one, of course, being placed in critical tab, and we can see the most informational ones being put in the informational category or group. So now, once we have vulnerabilities here, it's also really important to mention that not every finding coming from the /review scan is going to be directly related about the security. It can also be about the code performance issues. If the vulnerability is strictly related to security, it's going to have a CWE and specific number as a prefix, where the CWE stands for the common weakness enumeration, where we can use it as a reference to the finding. On the other hand, when it comes to the code performance issues, they are going to be very descriptive when it comes to naming the convention of finding. So for example, if I expand the medium tab and make this a little bigger, we can see here that, for example, in the medium tab, we have the name of the code performance issues, because you see there is no CWE, where it says avoid direct imports of the complete library to enhance the performance, clarity, and maintainability of our code. So we can see from here, we already got the idea of what the performance issue is, so we can go ahead and navigate to it and start working on it. Regardless of the finding, it's very important to tackle both security vulnerabilities and findings related to performance itself. But that's enough talking about that. Let's jump to the SQL injection.
But I really do like that /review agent isn't just focused on security, but performance as well. Because as we know, performance is they can get into, for example, our database or run queries that are going to exploit the performance of our database is another way of attacking.
Yes.
So really this agent comes double packed with not just reviewing security findings, but also performance as well.
Yes, that's absolutely true. That's why it's very important we take a look at both of the directly security findings and the performance issues. But for our first mission, as Michael was saying, is the SQL injection. So here we can see the SQL injection. If we only hover over the vulnerability, we're going to see the small window pop up for the, as you can see here on screen, for the description of vulnerability. But we can most certainly make this bigger by clicking on View Details. View Details is going to bring additional panel. So I'm going to put this one more down and then expand it here. Or we can just simply click it here. So now we have the name of the vulnerability, the CWE preference, and then the description of the vulnerability itself along with the impact. We can also see the suggested code fix preview is already working on providing the remediation code. But we're going to talk about that just in a second. Because when we see the details about the vulnerability, the Amazon Q/review agent already provides remediation for a finding. So in addition to that, we have detector library. If you're interested in how Amazon Q defines these findings and how it goes over to insecure coding patterns, you can also feel free to go ahead, depending on the language that you're using. You might have to choose Python or Java or other languages that are supported at this point. So let's go ahead and see what we're dealing with here. So we have the SQL injection vulnerability, and we see there is a potential SQL injection risk detecting our database operation. But to make it more interactive, let's go ahead and open again Amazon Q. Open chat panel and see the finding itself. So if I just click on the finding, that's going to redirect me to the vulnerable line of the code. In this case, this is 129. So following the description here, we see there is insecure coding practices here in terms of how we build the SQL query. Specifically, what we have here is a string concatenations related to the Python f string, where we concatenate the username to the already existing query, which Q finds out, and it says, this is insecure practice, insecure database operation. We should be using prepare statements or parameterized queries whenever we are executing SQL queries to make sure that we are avoiding the risk of the SQL injection. So here, as a malicious user, we want to understand where is the username coming from. Can I control the username in such a way to pass a special characters used for a SQL-specific payload so we can actually exploit this vulnerability? So here, before jumping to the remediation, let's go ahead and analyze the code and see what's actually happening. If you remember from Michael's demo, when he logged into the application, there is HTTP GET request being sent to the dashboard endpoint, which we can see on line 120. After that, we can see developers had already have in mind some access control issues that might arise here. So they are limiting you to see favorite books only tied to your username. But the problem here is how they do it. We can see here string concatenation. And then we can see finally 129 line, which is underlined with the yellow, that it's flagged for SQL injection because indeed we are concatenating the username. So as a malicious actor, as a hacker, we want to make sure that we understand where the username is coming from. So let's slide a little bit more up and see how it works. If you take a look at the register endpoint, once when we send the post request to it, we are in control of the username as a post request parameter right here. If you take a look at the code more closely, we see that the comments from developers. Input validation for potentially malicious usernames. But if you...
Wait a second. If I'm looking at this code, right, I'm looking at regex expressions that they've defined here. But are you leading me to believe that they actually didn't do the full thing in validation, that they're not actually parameterizing this?
That's correct, Agent Web. It's very weak. We can see full sanitization here. We can see just looking for certain special characters, as well as the script in this regex, which indicates to me this is just looking for the cross-scripting vulnerabilities, or maybe template injection vulnerabilities that we have here. At this point, I'm fairly certain I can see that we have SQL injection vulnerability in our application. And that's a big deal right now. Because SQL injection itself, it's not going to allow you to only dump the content of a database. You're not being tied to a certain table like we have here, for example, books. You can go ahead and migrate to other tables, such as the usernames and passwords. But it can also go more beyond that. Really, depending on the database engine that you have, it can also allow you to read the local files, to write the local files. And most certainly, under ultimate conditions, depending on permissions of the user running the database, can also allow you to achieve the remote code execution, leading to complete server takeover. So I'm really worried here because we have a simple application, but very first mission is already very unsecure here, and it's a hard challenge for us. So, but before diving to the remediation itself, let's go ahead and take a look how the malicious actor can actually exploit this. So navigating to the application itself, you remember, we are controlling the username, and we have to register malicious account first with the malicious username. So if I create a username, something along the lines like this. So what does it mean? And with a sample password, anything will work. What this means is that with single quote, we are escaping the current query, what we saw in a second. Then we have the additional operator, or the OR operator, and then something that's always universally true, like 1 is equal 1. This means that this way, I can fetch all the books, not only related to myself, from the database. And I'm finally using the minus minus to comment out the rest of the query to avoid any syntax issues or any additional SQL query that maybe come after my input. So here, I'm going to create this account. We can see here, because of the flow remediation, everything went through. There is not a problem with it. And then we can log in with this account. But bear in mind, this is a second-order SQL injection. It's the most straightforward one. Because once we register an account, you see nothing happens. But when the username comes to the play, when we log into the application, the SQL injection is going to be exploited. So if I click login here, we can see 4 books. Not only the book, because this is a fresh from the oven account, we shouldn't see any. But we see the Harry Potter, the Lord of the Rings, Great Gatsby, and what Agent Web added as Angela user. So this is a problem. But at first glance, it might seem innocent because we are just only able to dump the books from a database. But if you remember, we are not tied to a certain table or even a database. And depending on the permissions of the user running the database, we can leverage this and weaponize it even further to train with other vulnerabilities. So Agent Web, should you choose to accept to fix us this vulnerability with Amazon Q/review?
I got this. Let me show you how it's done. So the first thing we're going to do is we're going to jump back into the IDE. Now, I could spend my time going out on the web looking for the fix to this. But understanding and working with Amazon Q/review agent, I can come in and look at the suggested code fix preview. Now, knowing that, oh, this looks like secure code, I could quickly accept the fix. But we should go a little bit above that. So if you scroll down even a little bit more, we actually can understand why this fix is being recommended. So being able to see the actual implementation of the fix and what's being done here will really help us understand what we're trying to accomplish. So as you can see here, the specific code is trying to use a placeholder to be able to parameterize the actual username that is being inputted into the SQL so that we don't get SQL injection like we previously had. So you know what? I'm going to show you how to fix that really quick. You want to see?
Absolutely.
Boom. We're done.
It's already done? Wow, amazing.
First mission completed.
Check it out really quickly. So we can see now in 129, we are using the placeholder where the username was previously concatenated with Python F string. This way, the user input is properly stored, is treated as a raw text, and is being executed safely. So I would say we solved the first mission.
Yeah,
Web.
we're done with mission number 1.
Can you give us an overview of the second one?
Yeah, let's go to mission number 2. All right, mission number 2. Oh no, something's happening. It's not working correctly. There we go. We have 2 issues. This is going to be a problem. We didn't talk about that other one, package vulnerability. So let's figure this out. So first thing, we're going to have improper authentication. So what we're going to be showing is how there's JWT tokens that are in our application that aren't properly being verified. We're going to cover that as our first mission. We'll see that in today's example. But then we're also going to be talking about this package vulnerability, right? The ability for Q developer/review agent to also look at package vulnerabilities across kind of the industry. So let's go ahead and jump into the IDE and let's solve this one.
Absolutely. So for this mission, we have 2 vulnerabilities, the one we didn't expect. So we have no time to waste. Let's go ahead and see what we have. I'm going to pull up again the results of our security scan by clicking Amazon Q and navigating to the chat panel. As Michael was saying, we have the 2 vulnerabilities. The first one is the package vulnerability, so I'm going to expand a little bit more. This time, the vulnerabilities you can see here is coming from the requirements.txt, unlike the previous one, which was from our main application logic and functionalities. So if I click on the vulnerability, it's going to redirect me to the vulnerable line of a code. But here we have 2 findings, actually. We see that there is 2 yellow underlines for both Flask and the PyJWT. The problem with that is that we have 2 package vulnerabilities here, actually, instead of 1. But the package vulnerability for a Flask is a low-risk one, while the package vulnerability for PyJWT with this version is a high one. So we want to take the priority over the high one over the low one. So
Agent, have you ever heard of a critical package?
Not really.
Yeah, I get a lot of them. They come from Amazon, so continue on.
So here we can go ahead and click on View Details to get more insights about the vulnerability itself. So here we can see the PyJWT is a Python implementation for handling various actions when it comes to JWT tokens. The problem here that we have is a high-risk vulnerability coming from a specific version of the package. The problem here is that this version of the PyJWT is going to accept the non-algorithm, which is going to be, the JWT can be signed with it. So once when you go ahead and obtain a valid JWT token as a malicious actor, you can simply change the properties from the JWT body, sign it because JWTs are stateless authentication mechanism. Everything about the user is within the body of the JWT token, within the payload. So what we have here, if you get the value of the valid token, forge it, change the values in the body or a payload, and then sign it with non-algorithm, shoot it to the application. App won't be checking the signature in that case, and this can allow you to bypass the authentication or to escalate your privileges. Because using the JWT tokens in our applications really depends on the properties. Usually they are used for authentication or checking the access control. But the problem here is that even if we fix this vulnerability right away, we are not fixing the bigger picture here. Because there is not only a problem with what version of the package we are using, there is also a problem in the logic of our vulnerability, with how we are actually approaching JWT tokens. So if we take a look at the fixed code preview, we have the updating the major version here from 1.7.1 to the 2.4.0, which is the latest, the most up-to-date version when it comes to PyJWT. And now we are mitigating this vulnerability. But we're coming to fix later. The problem here is that what Michael was saying, or the agent web, that we have additional vulnerability, and that's improper authentication, which is coming from the app.py, specifically line 34. So what's happening here? We can see here the suggested code fix preview is once again run alphabetically. But let's go ahead, while it's doing that job, we can go ahead and read the description of the finding itself. So we have our code decodes a JSON web token, short for long for JWT, without checking the signature. This can be a huge security concern because you can go, nothing is stopping you as malicious actor or user when you have a token to simply forge its properties and then do as you wish. So here we can see that this is coming from the admin panel. We can see the comments from developers saying that we're currently testing the JWT implementation as they want to switch to it, maybe from the Flask session. And that's completely fine. The problem here is coming from the line 34, where we decode the JWT token without verifying the signature. So what does that mean? The thing is, if I get the token from this application, I can do whatever we want and then pass to the application. And application just won't check it at all. It's going to accept it as long as it's a valid format. In order to access the admin panel, as you can see on line 36, we are extracting the role from the payload and checking if it's an admin. If it's an admin, the user is granted access to the admin panel. Otherwise, the user is denied access. And the admin panels are very lucrative targets for the attackers because admin panel is going to allow you to access sorts of functionalities that are not available to regular user. It's also going to allow you to visit the data from the other users itself, such as resetting the password, visiting residential address, or something along those lines. So this is a serious security concern here. It's not only going to allow us to bypass the check, but also to escalate the privileges. So before going to the remediation portion, let's go ahead and actually jump to see how we can actually exploit this vulnerability. For this one, we don't even have to go to the browser. We can do everything from the terminal using the curl command. So if you remember, before I do a deep dive in exploitation, we need to have a token. So how do we get one? Let's go ahead and check it out. When you send the post request to a token endpoint, we just need to provide the username in the post request body, and then the username is being used as a user property when it comes to producing the JWT token or generating the token for us. The problem here is that we can see developers were thinking of possible access control issues here with the admin panel, so they are generating the tokens with a role hard-coded to the user. So do you think that's actually really going to solve our problem here? I don't think so either, because we are not checking the signature. Nothing is stopping me to change the role from user to admin once when I have a token. And we can see here the token is not properly protected either, so anyone can just get it. So without further ado, let's actually see how we can do that. So first we have to send the HTTP post request with a curl command to our application running on the local host on the port 5000, specifically in this case. And then we need to shoot the token endpoint. In the post request body, by using the D flag, we can provide the username John, for example. Once I send the request, we can see the application generates a JWT token for me, which is a base 64 encoded string. I can take it, and for ease of demonstration and understanding, we can leverage the additional website to visualize this very nicely. So for that, I'm going to go to the JWT debugger, and paste this token value. So here what we can see. We can see the user is indeed John, what we specify in the post request body, and then we can see the role is a user, which means that we correctly understand the application flow. So if I just take the token value as is and try to send a GET request to the admin panel, once again leveraging the curl command, I'm going to get access denied because my role is indeed not an admin. I have to provide the JWT token as an authorization header, type of a bearer token. I'm going to paste it and send the request. But access denied, you are not an administrator. That's completely fine. But if you remember, the root cause of our vulnerability is being able to access the admin panel without ever verifying the signature of a token. So here, I can go ahead.
Agent Markovich, I think I understand what you're saying. So you're saying that if I can just change this token or get access to this token, put it into this application here or this web interface, I could just quickly come in here, update this to admin, copy this new token, and then basically post it back into our application to be able to get the information that I need.
Absolutely, it's that simple. You saw just a second ago what Agent Web was changing the properties of a token. The token is being updated on the fly in the real time. So the token values or the properties of the body are changed from the user to the admin. So if there is a proper verification of a signature, this will be denied. But otherwise, because there is not, as we're going to see just in a second, while Agent Web is typing the command, we'll see that we're going to get access granted. The problem here is that even if we are leveraging the secret, or if you're leveraging the secret or to sign the token, we are not properly verifying that secret in the signature. As a result, we were able to access the admin panel, as we can see in the response this time. So the problem here is that the signature is not being verified, which is also what Q said here. So if we take a look, what's actually happening here when it comes to remediation itself is that we are importing the OS as additional module, as well as the JWT. We are importing specifically decode to also improve our application functionalities and performance. And then we're also importing proper exceptions here if there is invalid token error. So now this time, we see a comment where we are using the secret key, and specify the algorithm. It's very important to understand that Q is also going to give us the best security practices here, not only about decoding using the secret or the signature, but it's also going to say you should go ahead and define specific algorithm here that you expect, for example, HS256, because there is a lot of attacks around JWT tokens, for example, like related to the algorithms, like for example, algorithm confusion that you can leverage. So here, you can see here now that when we use the decode function.
So Agent Markovich, if I'm understanding this correctly then, this is very similar to, let's say, for example, someone with a mask that walks into an organization and goes to the security guard. The security guard knows this individual. But rather than asking them for identification, they say, oh, you're good to bypass because it looks close enough. It's kind of what we're running into with this JWT token issue. We're just being able to bypass by going through that security guard and saying, I know this guy, it's Bob, let's let him in.
Absolutely.
In fact, he's got a mask on.
As long as you have a valid format of a token, you can go through because application doesn't check the integrity. And that's exactly what the Q is saying here. You can leverage it for access control, as just what we see here for escalating our privileges for a regular basic user to be able to become an admin user. So here what we can see, just to continue with remediation very quickly, is that with the decode function now, we are storing the key value and pulling it up from the environment securely, from the environment variable called JWT secret key. So now when we provide the token, the signature is properly being verified, which means that once when the application generates token for me, if I do not know about the JWT secret key, the value of it, even if I change the properties, which I absolutely can, I won't be able to pass through because there is a signature mismatch. And this is very important to keep the integrity of the JWT tokens in one place. Additionally, it's very important to properly secure JWT secret key, making it unique, making it stored in a secure place, for example, like the environment. Because when you generate a JWT token, what can happen if you're using the weak secret key? It can also be extracted and brute forced using the brute forcing tool to get it, for example, like a hash get. So what we have here, we're going to specify the algorithm properly. We're going to specify the JWT secret key as our verifying the signature process, and we're going to hit accept fix. This is going to change our code on the fly, and now we mitigated even the second vulnerability. But remember, second mission has two vulnerabilities. So I still have to go to requirements.txt, and then to mitigate also the package vulnerability. But the package vulnerability, when it comes to remediation, is pretty straightforward. What we have to do is to update the major version here from the, if I can just find it, so the package vulnerability view details. And then what I have to do is to accept the fix. It's also going to update to the most recent version, which is a 2.4.0. Agent Web, can you help us with the third and final mission?
Yeah, definitely. So it sounds like we've solved 2 things today, or 3 in fact, but we still have a few more. Let's get to mission number 3. Now, this one's pretty straightforward, and we see this a lot, but hard-coded credentials, as they come through and they're getting detected, and this mission it's been really good, but I think these agents are really helping us. I mean, as we're going through, it's not only excuse me helping you, but I think this water's been poisoned. Agent Markovich, yeah, it's poisoned.
Seems that we just lost Agent Web. Thankfully, we have another agent / review agent. So what's the deal here? What's actually happening? Let me go ahead and switch to our code back. So the final, last but not the least mission that we have is going to be about the hard-coded credentials. We see if we expand the code issue step just a little bit, we can see the hard-coded credentials are now coming from the critical tab or critical group here. Hard-coded credentials, always a hot topic. It's always, if you open the cyber news or just IT news in general, you'll see a different incidents, different approach about the companies finding hard-coded credentials. Doesn't have to be directly on the client side, that on the server side, like we see here on the app.py line 11. It can be also happening still to these days, even being able to store those on the client side in a source code, in the source with dev tools. You can expect the HTML and see those there. It's still relevant to these days, unfortunately. So being a hot topic here, this is a very nice use case when it comes to / review agent and being able to spot these hard-coded credentials. Because in the end of the day, it's very handy to use hard-coded credentials when you are local testing or you're testing lower environments. The problem is when you have a huge code base with enterprise applications, if you keep going hard coding credentials in different classes, different functionalities, you might forget to remove and to properly secure those ones when you're ready to commit changes and to push production. So the problem here is that this is where the leaks are happening. You might be working with the open source project or just storing your project data or project code on the publicly available version in control systems like GitHub. Malicious actors are constantly browsing it. There is an automated tool constantly looking for secrets, and then they can be leveraged and exploited. Usually the consequence and the impact is huge. Being able to leverage unauthorized access doesn't have to be strictly like the API key hard-coded like here. It can be credentials for databases, for servers, for admin users. It can be API keys, as we can see here, or all sorts of secrets. It can lead, for example, to malicious actor just abusing your API keys and resulting in financial loss. Or it can be resulting in much worse cases, scenarios like data breaches and complete compromises. So if we take a look here, if I pull up the code issues panel, we can go ahead and pull the view details panel and then take a look what the queue has to say about this one. So there is a potential hard-coded credentials being detected. There is a code may contain sensitive data such as the passwords or API in our case. Hard-coded creds are the problem because they can be extracted and misused, leading to the unauthorized access or system breaches. So even if you publish the repository, or if you commit the code with the hard-coded credentials, there is additional burden on everyone, on developers and security teams. First, rotating these credentials, then the credentials are going to stay in the commit history if you just simply remove them but do not rotate them. That's another issue. If your repository has different branches, that's another problem. So you can see here there is additional workload for everyone. And that's why we want to make sure that we are not hard-coding credentials like this, specifically when we are pushing the code to the production finally. So here, the problem is that when you're a malicious actor and you find the hard-coded credentials like this one, first, you have to understand where they're being used. In this case, it's an API key, so we have to find out the endpoint which accepts the API key, which is used for the authorization of the user. And the second thing that we have to do is to have some sorts of luck, right? Because maybe this is a not used code anymore. It's not relevant. It's just there. It was used for testing a local environment, removed by developer simply forgets to remove it, or it just be used in lower environments, but we are now in the prod. So let's go ahead and understand our code to see how this is actually being used. If we take a look at the API key, we have to understand where it comes to play, essentially. So here we can see there is a private API route, and then we can see that API key is being pulled off from the HTTP header, X API key. And then if it's a mismatch between the X API key value header and then again with our API key constant, this is you're getting the access denied, invalid API key, and the 401 status code.
Otherwise, you'll be actually able to access the endpoint with a 200OK. Now that we understand here, this was a pretty straightforward in terms of the understanding the vulnerability and how we can approach it. So here we can go ahead and try to exploit ourselves. So if I clear the terminal and start everything from beginning, I have to send a curl request or the HTTP GET request to our application once again. And then we are interested in accessing the private API. Then, if you remember, we have to specify this X API key, and terminal remembers. Here we have the value for our API key. So API key, if you take a look at it, just one more time before we proceed with exploitation, is that it seems unique. It seems random, but actually it's not. That's additional talking point. So here we see only 1, 2, 3, 4, QWER, and then secret API key. And secret API key is just, in fact, name of the header. So it's not impossible for someone from malicious actor to completely guess it. So we may want to make sure that besides storing this properly, they're also unique enough, because we can store those properly in the environment or as secrets managers all day long. If they're simply guessable, it can be also find a common brute forcing word list. So it's very important to go and implement security depth, especially when it comes to these very sensitive credentials. So here, if I leverage this curl request and I simply send the GET request to our private API endpoint, we can see the confirmation message. We reached the private API endpoint. And this is a confirmation that this is a still valid code, this is a still valid API key, and this is a problem. Because API keys can be exposed, or any kinds of hard-coded credentials can be actually exposed for a long time before a team realizing it. This way, as we want to make sure that we understood everything correctly, if I simply just slightly change the API key, we can see now we are getting the invalid API key, which confirms this is a true positive, which confirms that I can access the private API endpoint this time. And then this is a problem, because just in the name of the path or route, we have the private API. The private API indicates maybe just accessible, it was meant to be accessible only by the employees, it was meant to be accessible only by maybe the business users, and it can hold a lot of data there. Additionally, being able to access a whole new API, that brings additional sets of vulnerabilities. You might be able to find other sets of vulnerabilities specifically for this API that we don't have in the code currently, but it opens the door for new exploitation possibilities. So what we have here is that if we take a look at the remediation, to remediate this, we want to make sure that we are storing the secrets in environmental variables or use secrets manager like the AWS secrets manager. So what's happening here in a suggested code fix preview? It's pretty straightforward. We are, again, similar to JWT, importing the OS module. Then we are removing the hardcode API key right there. And then we are creating a new one and then safely pulling the value for the API key from the environment. This time, only the application itself and developers having access to the server and these environment variables would actually able to see the API key value. If we plan, for example, to push this code to the GitHub, if it's, for example, open source project or just meant to be used by others, the other developers have actually to configure their API key environmental variable, or however they want to call it, and then we are properly secure, right? But there is one thing here. What if the storing the values in the environment just simply doesn't work for me? What if we can pretend that this is a Lambda functionality? What if this is a Docker container? Environment might not be just working for me, and that's completely fine. We have additional approaches here in remediations. What you suggested is about, for example, using the secrets manager, like AWS secrets manager. And then let's say I did Googling, I did my research, I really like the idea of storing the values in secrets manager, works perfect for me. Business logic is there, application logic is here, everything is fine. But I'm hitting some roadblocks and obstacles when I try to implement it. I simply maybe do not understand, don't have time to implement it. That's completely fine. So first, what we are going to do is to see here just for a second how we can leverage the Amazon Q developer besides the review agent for our educational purposes as well. Because not every time you're going to be familiar with the finding. There might be security vulnerability you're not very familiar how to actually confirm if it's a true positive when it comes to exploitation. There might be the way to, you're not very familiar with the code performance issues as well. So you can go ahead and hit the explain, which is going to show the content of our finding to the chat. And the queue is going to think about it and provide us an answer. This is great because we can learn more about the vulnerability and we are going to get very verbose output. So here we can see, if I make this bigger, we can see here that we are getting the CWE reference to our finding, that we are actually want more explanation. And we can see here that what is a CWE? We have the issues in our code. we can see the security impact. If we do not understand security impact, if it's a niche vulnerability or niche core performance finding, and then we can see recommended fix. So we can see here that essentially it's pretty much the same what we saw before. But now that the queue knows this context and it's aware of what I'm dealing with, specifically the hard-coded credentials vulnerability with specific CW number, now I'm ready to go ahead and ask further questions here. For example, if I don't understand, can you showcase me more details, simplify, or give me some resource on the web that I can take a look at it? Or simply in our case here, I can craft a prompt in something along the lines of, can you help me integrate AWS secrets, should be lowercase, secrets manager, in order to safely store value of our API key constant. And we can see here that now the queue is going to think about it, it's going to generate the specific code for it, and it's going to integrate the AWS secrets manager in our code in real time once we send the prompt here. Or maybe we just have to wait for some more time. But essentially here, we can see that now I'm not only mitigating the vulnerability, but I'm also, let's go ahead and try maybe the new window. I'm not only mitigating the vulnerability, but I'm also learning something new. So this way I'm combining the security and also different approaches. Because something that works for me might not be working for you when it comes to the business perspective, when it comes to the application logic. So that's why it's important to have different approaches when it comes to fixing the vulnerability. And what's also really important to mention, to say there is no one fix for everything. There is different approaches fixing the vulnerabilities. Of course, when you have a package vulnerability, there is one straightforward fix. But when it comes to the fixing different vulnerabilities, there is maybe different libraries, different approaches that might be working better for you. So we can see here.
Agent Markovich.
Yeah.
That was a doozy.
Agent Web, you're alive?
I'm alive.
Oh, thankful.
So, sounds like you've accomplished a third mission. What are we doing now?
What I'm doing now is I'm trying to leverage AWS Q Developer to help me to integrate Amazon Secrets Manager so I can properly secure the values of the API keys and other secrets in my code. So the way that if the environment doesn't work for me for whatever reason, pulling the values from the environment, I have additional alternative here. So what I'm trying to do is I'm having some hard time implementing the Secrets Manager. I do not understand how to do it fully, and I want to leverage the tool to actually help me do so.
You know, it's really neat because with Amazon Q Developer, we actually released this new feature that is a new agentic chat interface. So by turning and turning off this feature, you can actually have the code be generated within your IDE.
Oh, wow.
So it'll actually make changes to your code. So as you're asking these questions, not only can you just ask and get responses, you can actually work back and forth with Amazon Q Developer to be able to actually modify and change your code. So I'm glad to see that you already found this new feature. Hope you have found it useful.
Absolutely. So here, once we turn it on, we can, maybe we can ask the same prompt.
Go ahead.
Go ahead and try it. Even maybe back here, we can just copy it. Now when we have the new prompt, when we have the feature turned off, now the prompt should go ahead and be generating our code and modifying our code base to implement the AWS Secrets Manager to help us to store the values of the API key properly. So we can see here then start working. We can see the directory is being listed. If I expand this directory, we can see it's a bookfold directory or a folder of our application. And then we can go ahead and check in the specific dependencies, because if you saw checking for requirements.txt, and now we might be required to install furthermore. For example, Bodo 3 is what's needed as well. So we are changing requirements.txt on the fly. Now we're also making changes to app.py to actually leverage the Bodo 3 to create new AWS Secrets Manager client. So we can actually communicate from our account and in the same time fixing the vulnerability, but also fixing it the other way. So if we take a look here, if I close the code issues panel, we can see here that app.py's changes are being applied. Now we can see the code is being changed in real time. And then we are getting a new functionality, get secret. We can see also nice comments of it, retrieving the secrets from the AWS Secrets Manager. Specifically, we pass the region name, secret name that we want to retrieve and fetch. Now, this is, of course, coming from this can be also found in the AWS guide and documentation, how to implement the secrets manager. Now, we are pulling the secret with the get secret value. We're having some if-else block statements here, or the exceptions to gracefully fall if something like this happens. If you're trying to retrieve the secret that simply does not exist. And then finally, we can just let Q do its thing, finish our code changes in real time. With the green line on the very left, we can also see what is being changed or added. And we can see here that it's going to, if we take a look at the summary of what it did, we can see that first we installed and updated dependencies, because it's very important that we update requirements.txt accordingly. Or, for example, in Java apps, POM XML, if you're starting different dependencies. Now we are creating the secrets in Secrets Manager. We can change this, of course, accordingly as we wish and please. Then we want to configure AWS credentials in order to be accessed in the AWS environment, so we can also do that. We also have some tips here, for example, for the local developer, or if the Secrets Manager is not available, we also have a backup plan. To be able to fetch the secrets and access those credentials. And then finally, we have the final benefits here. The secrets are no longer hard-coded. The secrets can be rotated without the code changes, which is very helpful. Access to secrets can be controlled using the IAM policies. And finally, we have the fallback to environment variables in the edge cases when we simply cannot access Secrets Manager.
So rather than just getting a response or just like a one-time thing, it's actually going to give me the ability to chat back and forth with it as well. Mm-hmm. So as you go through Amazon Q Developer, you can actually accomplish your challenges and your missions, but also get the context as to how you're accomplishing that. With that being said, Agent Markovich, guess what? Our mission has been accomplished. We have secured the book vault. We do still need to work on that Secrets Manager integration, but at the end of the day, we've solved these 4 specific challenges today using AI-powered tools. So while we thought this mission was impossible, it was pretty practical. And one of the things that we wanted to highlight was that some of the takeaways that we had with FINRA when doing this pilot with Q Developer is that they were able to actually test and go through and be able to see the power of Q Developer and what it would do for them. Some of these numbers are actual results that we got from the pilot as they were going through. And they were able to actually work with us to understand like OWASP top 10 coverage, to understand where are things going in the industry with Q Developer. As we're continuing to update our tests and things behind the scenes with Q Developer, we're always continuing to have that continuous learning model so that you can see that the security vulnerabilities that exist in the world today or that are coming up are integrated into Q Developer. With that, Agent Markovich, we've accomplished the mission.
Absolutely. You saw that even our application was pretty straightforward and very simple in scope. That does not guarantee it's vulnerability-free, especially we have some very serious and security flaws that we had there. So I'm very glad that Q was able to find it with /review agent, and we were able to mitigate those.
Awesome. Well, thank you, agents. Hope you've been enlightened and that you were able to take those tools and learnings back with you. Thank you.
Thank you.